Hello, you are most welcome. I'm teacher Ivan from WUNNA Educational Services. In this particular video, we shall be looking at weight and the comparison between weight and mass. We've seen that mass is defined as the quantity of matter contained in any object, and mass is measured in kilograms as its SI units. Mass is still measured using instruments such as the beam balance, which has types of beam balances. However, mass can also be measured using a spring balance that has the scale for mass. Majorly those that we use in the physics laboratory have the provision of getting mass on them. Then, what about weight? Weight is measured in newtons by a spring balance. Weight is defined as the force of gravity acting on a body. And since it is the force of gravity that acts on a body, therefore, weight is gotten or obtained by the product of the mass of the body and the acceleration due to gravity. There is a disturbing question. When does mass become weight? Mass becomes weight if it is measured while the body is freely hanging. If you have ever noticed that whenever they are measuring weight of a substance, that substance or the body is always hanged with its end hanging in air. So simply, weight is measured while the body is hanging, meaning it is being acted upon by the force of gravity. Whereas for mass is measured when pressed on the scale pan, meaning it is not acted upon by the force of gravity. So when does mass become weight? Simple. Mass becomes weight if it is measured while the body is hanging freely. Then, from the formula for weight, which is mass times acceleration due to gravity, we shall have the units derived. Mass is in kilograms, acceleration due to gravity is in meters per second squared. So 1 kilogram times 1 meter per second squared gives us 1 Newton. So that means that we shall define a Newton as the force that acts on a body of mass 1 kilogram when it is accelerated at a rate of 1 meter per second squared. That is a Newton. Then we shall look at examples that involve calculation of weight. Number 1, we are told to calculate the weight of a mango whose mass is 300 grams, and we are taking the acceleration due to gravity g as 10 meters per second squared. So from the formula for weight, which is mass times acceleration due to gravity, therefore we shall always change the mass to its SI unit which is in kilograms, by dividing by 1,000. Then we multiply by the value for acceleration due to gravity, which is 10. So that will give us 3 newtons as the weight of the mango. Let's continue. Otherwise, for now, we shall pause from there. Maybe to talk about is the difference between mass and weight. We shall start with their definitions. We shall also differentiate them using their SI units. We can differentiate them using the instruments that are used to measure each. We can also differentiate them by their nature of quantities, because mass is fundamental, weight is derived. Still, mass is a scalar quantity, weight is a vector quantity. Mass is measured in kilograms, weight is measured in newtons. Mass is measured using a beam balance, weight is measured using a spring balance. Mass is constant, whereas weight varies as the acceleration due to gravity also varies. Those are some of the differences. In physics, when giving differences, we use each aspect for a particular difference. If we're using the definitions, then define mass and also define weight. If we are using the apparatus used to measure each, then state, don't mix up concepts. For instance, don't say that mass is measured using a beam balance, whereas the unit of weight is Newton. We define using 1 by 1. Otherwise, I beg to pause from here. We meet next time for another lesson. In our next lesson, we shall be looking at density and relative density. Otherwise, I wish you good luck, success, and enjoyment in your academics. I'm teacher Ivan from WUNNA Educational Services. We are here to make your learning easy, convenient, and reliable. Otherwise, we meet in the next lesson.